All right, so there are two new theorems we're going to discuss in this section, 7.5, proportions and triangles. The first one is called the side splitter theorem. And what this theorem tells us is if we have a segment in the middle of our triangle that is parallel to a side, and let's see, let's call this x, 16, 5, and 10, then a proportion exists between these segments. Now, this is the only time, if you don't have parallel lines or you're not certain about parallel lines, you can't assume that you have this proportion. You would have to have full sides of each triangle to set up a proportion. But this is actually a nice little shortcut. These parallel lines tell us that x over 16 should equal 5 over 10. So it almost, you can almost see the proportion there, all right? So we have x over 16 equals 5 over 10. The key here is you need the parallel lines in order to do this. Okay. From here, we're solving that proportion. So you would have 10x equals 16 times 5, which is 80, yes? Divide out 10, so x should be 8. Now, just to have you guys double check, would it work if I said x over 5 equals 16 over 10? Would I still get the correct cross product? I would. What you can't do is x over 10 and 5 over 16. Then the cross products don't work. Yes? You can, but what I said earlier is just because you can do something in your head because it's easy and you can go, oh yeah, that's half, still get in the habit of setting up the proportions, because if these were algebraic expressions, then you need to know how to set up the proportions. So they're giving you the ones that are easy and you can look at it and go, yep, x should be 8. It's a good double check. So the easy ones are so you guys can do them and double check them, but set them up so you're in the habit of knowing what the proportion is, okay? All right, so I'm going to give you guys one to try. Again, if you do not have those parallel lines, you cannot set it up this way. Okay, so we're going to take a minute and have you guys try this one yourselves. So before you go any farther, just to make sure you've got the setup correct, what would my setup be? X plus 1.5 over, yep, over what? X equals 5 over 2.5. And one thing you want to be careful of when you're cross multiplying is with this piece right here, we want to make sure we're distributing, otherwise you're not going to come up with the right result. So we have 5x equals 2.5 times x plus 1.5. 5x equals 2.5x plus 3.75. Subtract your 2.5x. So we get 2.5x equals 3.75. Divide out 2.5, and x is 1.5. Okay, now the first thing is, if you set it up correctly, that's the new concept. Okay, if you set it up correctly and solved correctly, fantastic. If you didn't solve it correctly, that's algebra. Okay, we do need to remember those algebra skills. Okay, now there's also a corollary to this idea up here. Right, the corollary tells us if we've got 3 or more parallel lines, and we have, now I'm not putting numbers in for this one, but if we know segment lengths, or we're looking for a segment length, since this eventually is going to create a triangle anyways, the side splitter theorem still fits into the same idea. You can still write the proportion A over B equals C over D. Okay, so that same proportion still exists, even if you don't have the upper part of the triangle. So, for example, so if we have a problem like this, you're going to have to set up 2 different proportions. Okay. Now some of you might be looking at the bottom here thinking, ooh, we've got x and y in both of these. I'm going to have to find x and use it to find y. I wouldn't do that. You're going to have to find one at a time, obviously, but the first proportion I would set up would be 6 over x equals 5 over 12.5. Okay, that's using 3 out of 4 known values. Okay, but I would not use x in this other proportion. We can pretend that x is not there because we're still dealing with all parallel lines. And what proportion could I set up using 3 values that I was given? Yeah, 6 over 9 equals 5 over y. That way, if you mess up x, you still have a shot with y. Okay, you're not plugging in something that's wrong, because that will automatically be wrong. So we're going to say 6 over 9 equals 5 over y. And I'm not using something I just found, which could potentially be wrong. Okay, so in this case, we have 5x equals 75. Divide out 5, and x equals 15, right? And over here, we have 6y equals 45. Divide out 6, and y is 7.5. Do you guys understand why I was able to ignore those in the middle? As long as all of these are parallel, then the top is parallel to the bottom and the second is parallel to the last, right? They're all parallel. So it doesn't matter which pairs I use, as long as I use that pair and another pair that's along the same lines. Okay, and there's one other theorem that we're going to look at, and it's the triangle angle bisector theorem.